ನಾವ್ ಏನೇನ್ ಕಲ್ತಿದ್ವು ಅಂತ ಕ್ವಿಕ್ ರಿಕ್ಯಾಪ್ ಮಾಡೋಣ. Last to last class
Mm.
ಅಲ್ಲಿ we learned about quick partition. There was a main function, we defined an array, we printed unsorted array, then we called quick sort function, and we passed array 0 as low and n1 as soon as high. And if condition ಹಾಕಿದ್ವಿ, if the high was less than low, then the condition would execute. In that, we uh, we defined partition index and we called partition function for that. Yeah, we defined partition index and we called partition function for that, and we passed array and we passed low and high. And then what, we swapped some numbers in between. There was a condition, a partition which would partition the pivots right side to greater numbers and left side to small numbers. And then we returned I plus 1, and then we recursively called quicksort again to sort the left side of the array, and then we called quicksort again recursively to sort the right side of the array. You can imagine this as a tree. Okay, after this we learned about linked list. Linked list are of two types, that are singly and doubly. In singly, it is a data structure which has a data and a pointer, and the pointer is pointing to what, the next node. Okay, then after that we learned about doubly linked list. Doubly linked list is a data structure which has data and two pointers. The pointer is pointing to the next pointer, and the previous pointer is pointing to what? Previous node. Okay. Uh, in single linked list, we can traverse only from one way, and in double linked list, we can traverse from both the sides, that is from head and tail. So here, uh, traversing becomes a lot easier in doubly linked list. Okay, then we implemented the linked list in C. We called the main function, and we traversed it, and then we created some nodes and we displayed it. Before traversing, what we did, before displaying what we did, we took a temp pointer and we pointed it to head, and then we traversed the temp while printing all the data present in our list. Okay, this was our singly linked list implementation. So that was it, and then we moved to stack. Yet we didn't do doubly linked list still, but we'll soon do doubly linked list when we'll get a good hold of big O function and omega function and all that asymptotic notations. Okay. Then we move to stack. Stack is what? Stack is a linear data structure that follows LIFO, that is last in first out or first in last out principle. Okay. We can implement stack in arrays or linked list. Some operations we use in stack are push, pop, and peek. Push to add an element in the stack, pop to remove an element from the top, and peek to retrieve an element from the top. That is, we do not delete the element from the top, but we just get the information on what element is present at the top. And today our topic is queue. So let's see what queue is. What is queue in data structure? A queue is a linear data structure that follows the first in, first out, that is FIFO principle, or we could say last in, last out principle, meaning the first element added to the queue is the first one to be removed. Okay, data is inserted at one end called the rear NQ and removed from the other end called the front DQ. This is smaller to a line of people. Okay, let's see what does this mean. Let's take an example. So here we have a queue. Okay, and this is what, this is the front, that is the head, and this is the rear. You can imagine queue as what? A straw. You can imagine a queue as a straw which has what? Which has uh, open, which is open from both the sides. Okay, a queue is what? A data structure which is open from both the sides. That is, we insert an element from the back and the elements come out from the front. That is DQ. You must have You may be familiar with what when we were small. You must be familiar with some pen pencils which use this Q method. You could just remove the front what lid and you could insert at the back. Are you able to imagine?
Yes.
Ah, that when we were small, we used to have one pencil-like structure in pencil-like structure in which you used to remove the front lid and insert at the back. Again, you used to remove the front lid and insert at the back. That's the Q. That is what? That is Q in move. Okay. So here, at the rear end, we insert an element. What is this insertion called? We call this as NQ. Okay, and from the front end we what we dequeue the element, that is we remove or we use the element if we need it. Okay, so this is what this is Q. Now we know what Q is. Now let's see where all this Q is used. A line of people. Think of a line at a grocery store. The first person to get in line is the first person to be saved and leave. So in real world analogy, yeah, queue can be applied here. And printer queue. When you send a document to a printer, it's added to a queue. The printer processes the documents in order. Okay. So if you want anything in order or something like that, then we use queue. Okay. This was pretty much about queue. And now we have the basic idea of queue. Okay. What are the operations performed on queue? We perform basically two operations, that is NQ and DQ, and also we can also peep the elements. Now let's go to our implementation of queue. Now here we can actually implement queue in what? In arrays also, and we can implement it in linked list also. Let's take the example of array first. We include what? We include input output stream, then input output header files, then library files, and we include boolean header file. Okay, then we defined a max size equals 100. That means this cannot be changed. And we defined a type defined data structure in which we defined an data array, uh, that is of max size 100. And then we defined an variable of type int front and rear and size. Now why do we need size? Because we have to constantly keep on updating our size on what is happening. Okay, then what we call this struct, we gave this struct a name arrayQ. Okay, then what we initialized rq. No, before this, what we defined our struct, then directly let's move to our main function and then we'll come back. Okay, in main function, what we did, we declared an array q with name q. Then we initialized q and passed the address of the q. Let's go now to what initialize q. Yeah, here it is. We initialized q array q star. See, we passed the address over there, so it's pointing here, and we retrieved it. That is, we received it. Then q dot front. What does this mean? It's a struct data type. You can also write it as star q dot front equals 0. So our front is what? 0. Why is our front 0? Because our q is empty.
Empty.
Yeah, that's it. And rear is -1. Now, why did we keep our rear as -1 and our front as 0? Because if our front is 0 and rear is 0, that would mean that there is one element in Q. Getting my point? See, understand from this
Okay.
image, if there is one what node, then if the front is also this and the rear is also this, what did that mean? That mean that this there is one element present in RQ, but RQ is empty. That's why what we do, we keep our rear -1, which which means what? RQ is empty. Understand why we initialize it to -1 and not 0, then um, because our queue is empty, so the size will be what? 0. Okay. After initializing it, then we come to our main function and we enqueue. We enqueue 10. That is what? We insert 10. From where do we insert 10? We insert 10 from the rear. Okay. We come back here and we insert it. So before that, what we do, after void, we check if the array is empty or not, and we check if the array is full or not. Okay. If uh, it is empty, then we return this, and if it is empty, then we return this. See, double operator, what does double operator mean? It checks the equality. It's not assigning it, but it's checking whether these both are same or no. Understand? And bool is a what? Bool is a return type of it returns only 0 or 1. So if this is true, it returns what? 1. And if this is false, it returns what? 0. So that's it. And here also we are doing the same. Then here also for enqueue also we are using what data, what return type? We are using bool return type. Why we are using bool return type? Because we have already passed our what? We have already passed our data, and we know that enqueue is what? Enqueue uh, enqueue what initializes data from the rear end. So we do not have to define it particularly from which side we have to insert the data and all. So we can just return true and false if the enqueue was um, successfully done or if it was failed. Okay, so we only need what? Two types, that is a true or a false. So we are using what? A Boolean type. Understand? Now what we do? We enqueue it. We received the what? We received the address and then we received the value. And now we are checking. Now we are calling isFull function from here. That is this isFull. Now what will this return? This will return false because our queue is what? Our queue,
Empty.
yeah, our queue is empty. Therefore, this if condition is false. And if this is false, then this print statement will not execute. If it would be true, then this print statement would execute that queue overflow cannot enqueue. What is queue overflow? Queue overflow is now we have our fixed size that is 100, and if our index 99 element at our index 99 all the elements are filled, then what did that mean? It means that our queue is filled. Understand? And then it will return what? Overflow. The same case happens in the stack as well. Okay, and then we return false. But here what's happening? Our queue is empty, therefore this statement will not execute. And what before what initializing the value, what we are doing? We are increasing our rear. That is, we are what? Our rear will be what now? Our rear will be 0. Understand? And once our rear will be 0, then we add data at which position? At rear position. What is our rear position now? Rear equals what? 0. Why 0? Because initially our rear was what?
-1.
-1. And
Minus.
then when we increment it, what did our rear become? 0. And data of at data of 0, that is at data of index 0, we are inserting the value what? We inserted 10, I guess. Yeah, we are inserting 10. Then what? We are increasing the size. And when this enqueue is what? When this enqueue is perfectly, that is successfully done, we return true. Understand what is enqueue?
Okay.
That
Understood.
is inserting an element at the rear end. Then after this, what we call we insert the same way enqueue. We enqueue 20, 30, 40, and 50. And then let's display. Um, let's go to our display function. What we passed the water, we passed the address of our queue, we display. Now here we are checking is empty. Is empty is what here is empty. If queue size equals 0, that is it returns only true or false. See, if this condition becomes true, then what happens? This means that our queue is what? Empty. And if our queue is empty, we cannot display our result. That is why we are checking whether our queue is empty or full. If this condition becomes true, then we return queue is empty and we return. And if not, uh, then we move further to execute. Printf printf queue equals, then this is for just a better understanding. Then we use a for loop. We could also use a while loop. Okay. For we are initializing I equals queue dot front. Now what is our front? Our front is what? 0. Understand?
0.
Yeah, our front is 0. And while I is less than equals to q dot rear. What is our rear now after inserting 10, 20, 30, 40 and 50? What is our rear?
4.
Yeah, our rear is 4. And then you know the condition for this for loop. We initialize it, then we have a condition, and then when the loop executes, we then increment it. So what we print? We print data of what I is what now? I is 0.
Yeah.
Ah, what will be at I 0? That will be 10.
10.
Then we go again, we increment I, and then I becomes what? I becomes 1 is 1 less
1.
than equals 4. Then yes, that is true. And then we print 20, and the same way we print 30 and 40 and and we print 50. And after this we increment I again. Now I becomes 5. 5 is not less than and not equal to what? 4. Therefore this for loop terminates. And then we print what? We print next line. We displayed it. Now we will dequeue it. Now here also we do not need to specify our position on which element do we have to dequeue, because the dequeue is um, from the front element. As we saw in the definition of the queue, what happens from the rear end we enqueue and from the front end we dequeue. So so what we have to do? We dequeue it from what? We dequeue it from which side? We dequeue it from front side. Okay.
Front end.
Yeah. Let's move to our dequeue function. Yeah, here it is. Now in dequeue we are checking if the RQ is what? Empty or what? Now if it is empty, what we return? We return false. That is queue underflow, cannot dequeue. And if it is true, then we what? We return a value. Why are we returning value, and why are we not taking boolean type? Because what we are doing here is we are directly printing, and when we are calling this function, we need to print something, because we are using what? This percentage d. What does this mean? That means print print this dq. Okay. Therefore this d is of what? Of int type. So what type of return type we need here? We need of type int. So we are using int type in dequeue function. Or we could use just what? We could use dequeue as a boolean, and then we could go to our rear, and then we could see the size, and then we could print. So that would be a lot of waste of space. Therefore what we are using int return type. Okay, then we dequeue and we return value. Okay, here we check whether the queue is empty or not. If it is underflow it means what? The queue is empty. If the queue is empty, we cannot display any output, or we cannot even dequeue it. Okay, Then we initialize our value to what? Q dot data equals front. Because why are we doing this? We are doing this because our DQ works from what? From our front. Yeah, that data and Q dot front. Where does this lead to? On data of 0. So data of index 0. What is that index 0?
10.
10. Yeah, exactly. Now 10. Now what we're doing, um, now once we have stored the value, now what does our value hold? Our value hold 10. Okay, understand? Our value hold 10, and then after we initialize it to value, what we do? We increment our front. Understand why are we incrementing our front? Because once we dequeue the element from here, our front shifts from what? From this to our front shifts to this. 4. Understand? And now our queue has how many elements? One, 2, 3, 4, 5 elements. Earlier it had 6 elements. But the head is removed and there is a new head. That is, from our pen pencil, you could imagine when a lid is inserted at the back. Just forget about inserting at the back. When our lid is removed from the front, a new lid comes out. What is that? A new head, a new lid, by which we can write again a smoothly. Okay. Then what we decrease our size because we are not inserting it anywhere, or we are what we are using it. We are just using it. We are not removing this and inserting it over here, or we are not doing anything. Therefore, what? The size decreases. Understand?
Yes.
Okay. Then we reset our pointers when queue becomes empty. So if our queue becomes empty after dequeuing, after one point, what happens is our queue becomes empty. Then if our queue becomes empty, that is, this will execute and also this will execute because both have the same conditions, which means our queue is empty. If our queue is empty, what happens? DQ does is the DQ what? Which it says us that queue is at underflow, and then it resets. It resets the front to 0 and rear to -1, which indicates our queue is what? Empty. Okay, it would be better if we would just remove this from here and add it over here. Now it would make little sense, I guess. So first, what does DQ checks? It checks, or we could just remove this if statement only. We could just copy this and add it over here. And we could just remove this if statement. Yeah, this would make even more sense. Getting my point? What is happening?
Yes.
Uh, then, after dequeuing some elements, what we do? Then we dequeued what? We dequeued here what? 10, and then we dequeued 20. Yeah, and then we displayed it. Now when we display, what are all the elements we have? 30, 40 and 50. Here what are all the elements we had? 10, 20, 30, 40 and 50. And then what we do? We peek the element. Let's move to peek function and see. What does peek do? We just retrieve the information. We do not change any size, we do not change any head. That is, do not change any front, and we do not change our tail. That is our what? Rear. Understand? Now here we are again checking if the queue is empty or not, and then we are returning the data front. That's it. That's it happening over here. No more operations. We are just what? We are just peeking. Okay. Understand what is happening here? And then let's move to get size. What will be our size now? Earlier, what was our size? Our size was 1, 10, 20, 30, 40, 50. Earlier, our size was 5. And then we dequeued two elements. Earlier, our size was actually 0. Then we enqueued 5 elements, then our size became 5. And then we dequeued 2 elements, then our size became what? 3. Understand? Now let's run this terminal. Yeah, see, our queue had what? 10, 20, 30, and 10, 20, 30, 40, and 50. Um, you're able to see, I guess.
Yes.
Yeah, it's visible. Yeah, we had 10, 20, 30, 40, and 50. And then we dequeued the element from the rear end, that is the 10, comes out. That is, it becomes deleted, or we may use it for different functions. Okay. Then we dequeued 20 because our rear had what shifted to 20. That is our new what a front, sorry, front. Our front had shifted to 20. So what was our new front? Our new front was 20. And then we dequeued it. Deque happens from the front, so our front was 20, so 20 comes out again. Then what? We queued again. Our queue had now what? 30, 40, and 50. Now what was our front element? Our front element was 30. And what was our size? That is what? 3. That is what happening here. Understand? So this was queue implementation in what? In arrays. Okay.
Okay.
Now let's move to um, implementation of queue in linked list. Okay, now here uh, we can use stacks in arrays, linked list, and many other data types. Let's see, but for now our better understanding, we only know arrays and linked list, so we are using arrays and linked list everywhere. Okay, here we included input output stream, library stream, and bool stream as earlier, and we defined a node that is of type struct, and we have what? A data and a pointer which is pointing to our next node. So from this definition, it is clear that we are using what? We are using a linked list. Of what type?
Singular linked list.
Yeah, we are using a singly linked list. And then uh, now, because this is a linked list, we need more pointers. So we defined what? Another struct in which we have two nodes. One is pointing at the front and one is pointing at the rear. Understand? Now, just
Yes.
imagine how many pointers do we have actually here? We have a pointer which is pointing to head, that is front pointer, and a pointer which is pointing that is a head pointer. Then we have a rear pointer which is pointing to the tail, and we have some many pointers in between the nodes which are pointing to next nodes. So it's all about pointers here in linked list. Okay, so that is why pointers is very important. Okay, then what we gave this struct a name, that is linked queue. And now after defining these both struct types, let's move directly to our main function. In our main function, we defined a linked queue, that is queue, and then we initialized the link queue and passed the address of queue. Let's go to initialize. Yeah, here it is. We initialized the linked queue, and what we did, we pointer front, that is our pointer which is at front, our front pointer is to null, and our rear is pointing to null, and our size is 0. So what does this mean? This means our queue is what? Empty. Understand?
Yes.
Because our front pointer is pointing nowhere, not even at empty space. So it is what? It is null. Empty space is something, but null is absolutely nothing. So our front pointer is pointing nowhere and our rear pointer is pointing nowhere. Therefore, our queue is what? Empty. And now after we initialize it, let's move again back to our main function. This statement executed. Now what we enqueue, we enqueue linked queue. So here enqueue does not change. Enqueue always happens from what end? Always happens from rear end. Understand? So this is just like what adding the elements in a linked list from the tail portion. Understand? That is we could also say this as a reversed linked list, which we had implemented in our linked list video. In that we implemented the linked list from the front, and here what we are doing, we are implementing it from the back. Understand? That is what happening here. Let's move to our enqueue function. Yeah, here it is. We passed the address, we received it here. Then we passed the value, we received it over here. Then new node, we defined a node type, a new node, and then we called create function. Now let's move to create function. Let's see where create is. Yeah, here it is. Now create is a function of return type what? Node. Understand? Return type, not node, return type pointer. And we are returning a new node. Okay, then create, we passed a value in the create. That is what value did we receive here? I'm hoping it is 10. Yeah, it is 10 actually. So in our enqueue we received 10, and then we passed the value same here to the create function, which is 10. And then we move to create function, the value is 10. We created a new node, and then we know the use of malloc. I hope you know the use of malloc now again. See, malloc, what does malloc do? It gives us some space. That is, in our RAM, it provides an empty space of size node, and we receive the pointer for that empty space to our new node. That is what happening over here. Understand? And then we check if our new node is given some space or not. That is, if our new node is actually pointing to some empty space or not. And if it is not pointing to our empty space, then we return memory allocation failed, and then we exit with failure. Now, if that was successful, what we do? Uh, New node's data, that is new node dot data, we assign it to our value, that is 10. And new node dot next will be our null. Now our linked list has what? Now before this,
One element.
one element. And what is it pointing to? It is pointing to null. Understand? Now we return new node. Where do we need return new node? Here. Our new node. Okay. Now is empty linked queue. Now we check whether our queue is empty or not. We move, that is over here is empty linked queue, and we had passed the queue. I hope this should be address of the queue, but never mind. Let's see what if we get an error, then we'll change this to address of queue. Okay, because we are receiving the address of the queue here. Well, it doesn't matter actually, because we're using bool type. We just want to return whether it's true or false. So it doesn't matter. Yeah, it doesn't matter. So what we are doing here, we are returning whether our linked queue is empty or not. Now, if the size is empty, then what happens? Then our linked queue is what? Empty. And if the size is not equal to 0, we return 1. That is what? False. So here, if condition is checking. Now, if this is true, then our queue, now our size, now just let's go a 2 or 3 steps back. While we are creating this queue, let's move here. We did not talk about size. Understand? Did we talk about size over here?
No.
No, we did not talk about size. And here also we initialize the size. but we do not we declared the size, but we did not what we did not initialize the size. Okay, so what is our size actually? Here we initialized the size to what? We initialized the size to 0. So here, now if we run this condition is empty linked list queue, what will this return? This will return true because our size is what? Our size is equal to 0. And this if condition executes now. Understand what is happening? Because this
Yes.
is our front element. Therefore, this return will be what? 0. And if 0, that is if 1 actually, if 1, then if 1, that is if true, then our front is our new node. Understand? Because we are adding a new node, which is the start element, which is the starting element of our queue. Therefore, the starting element of queue must be where? At the front. Understand? Now, if this this if statement executes, and then this else statement will not what execute, of course, then will what will shift our rear to what? We do not shift actually. We assign our rear to what? New node. Now, imagine, just imagine, this is our node, and our head is pointing towards this. Our tail is pointing, that is, our rear is pointing towards this. Understand what is happening? Our rear is pointing toward new node. Our front is pointing to what? New node. So we have how much elements? We have one element. And then now we increment our size to what? 1. What is the size now?
1.
Our size is 1. Yeah, understand. Now after enqueuing our linked queue, we move back to our main function. We enqueue 10, 20, and 30. And then let's move to the display function. Now here what happens in display, we are checking whether our queue is empty or not, and we are returning whether our queue is empty or not. That's it. Then we are printing, that is link queue, and then we are printing from the front. Now here we can use for loop also, but it is better to use while loop. Okay, why it is better to use while loop? Because for loop takes a little amount of time when compared to while loop. Okay, that we will see in what time complexity. Okay, while printf data dot current. What are we printing over here? We are printing now. What is current actually? Current is q dot front. Understand? What is our front here? Our front is what? 0. So what is at zeroth position? That is 10. Getting my point? Understanding? You have to visualize. And then what we're doing, we are initializing current to current dot next. So what will be our current be now? Our current will be what? The second element. And then what? While current is current true, yeah, it is. Then we move to 20, and then we move to 30, and then after we move to 30, our current dot next will be what? Null. So while our current will be null, if this current becomes null, what happens? This while loop terminates. That is while loop what? Fails. The condition fails because this while loop has a condition only of true or false. So this while loop fails. And then we printed 10, 20, and 30. Then we print next line for a better understanding. And we print what? We print the pointer which is pointing at the front. We print the pointer which is pointing at the rear. And we print the size. Okay. Now why are we using this void type? This is typecasting. You guys know, I guess. This is typecasting. Now, what does P, what does this P indicate? It's a pointer type. This is also a pointer type. And this is what? This is an integer type. Just from this. Now, if we print this statement, if we print this statement, what should be our output? It should be two hexadecimal numbers. One is pointing to our front. That hexadecimal number is what? That is a pointer. That is what the address. Understand? And then this is a
Yes.
hexadecimal number, and this is what a type of integer. Understand? You'll get more clarity when we print this statement. Okay, then when we displayed this, let's move to print. Let's move to DQ. Now we know from where does DQ happen. DQ happens from the rear side. Understand? DQ happens from what? From rear side.
Front side.
Yeah,
Front side.
from front. Sorry. Yeah, from front. So DQ happens from front. Let's move to our DQ function. So where is DQ? Yeah, here it is. What we passed the address. We only pass the address, not the value. You know why it is? Because we are dequeuing it from the front. Now if is empty linked queue, that is we are checking if the queue is empty or not, and if it is empty, we say it's underflow. Okay. Then what? We do not um, take the front pointer directly and then we do it. We initialize a new pointer, temp. Understand? Because we don't want our original elements to be changed. And then when all the temp is successfully done, then we resize it. And then we move our front also. Understand? So we take a new pointer temp which is pointing to front. Understand? And then we initialize the value for the temp value, and then we initialize value for what? Temp dot data. So in front, what element is at front? 10. Yeah. Then what is that value? 10. Understand? And then q dot front, we initialize this to q dot next. So q dot front dot next. So what is our new front now? Our new front is pointing to, our new front is pointing to what? Our new front is pointing to um, the next element. Understand? And then when all this happens, we do not want the temp now. Now, because everything happened greatly, that is, everything happened clearly without any errors and all, then now this pointer, we don't want this pointer. So what we do? We remove, that is, we delete or we free the memory. We free the temp pointer and then we resize it by decrementing. Understand what is happening in DQ?
Yes.
Ah, then we again, if this and these statements are what? Same. Is empty queue is what? Same. And when if this statement is true, then what? Our queue is what? Underflow. That is, our queue is empty. Therefore, we uh, q dot rear equals to, we initialize it to null to indicate that our queue is empty. Then we return what value? What is our value? 10. So what will we print here? DQ element is what? 10. And let's just not print this statement. Okay, let's remove this because we have only three elements in our queue. So this is 10. Understand? And then we print what? Peak. We peak the element. Now, when 10 is dequeued from our queue, how many elements are remaining in the queue?
2.
Two elements. Yeah. Earlier we had how many? Three elements.
3.
Yeah. Now, if we peak, what will we see? We see what? 20. At what end? At front end. Understand what is happening?
Yes.
Now, let's move to our peak function. Peak function, peak linked list queue. Then we passed what? Queue. Now, because these are linked lists, so I don't think we need to pass address over here. Okay. Then where did our peak function go? Yeah, here it is. We return of return type what? Whether true or no. We returned an int type return. Then we passed it. We checked whether our queue is empty or not. And if it is empty, we return just -1, which indicates that our queue is empty. Understand? And if our queue is not empty, we return queue.front.data because we are dequeuing from which end? We are dequeuing from front end. So
Content.
we will peak from what end? We will peak from front end. Understand what is happening?
Okay.
Hmm. So here peak element. So this was our peak element, and then we return 0 because it's of return type int. Okay, so this is what is happening over here. And before then after all this, what happens? We what? We free it. Uh, we free our what? We free our queue. That is, if our queue is empty, or let's say we want to delete our queue, what we do? We call this free queue function. And what does this free queue function do? It dequeues all the elements. And in the dequeue itself, what does it do? In the dequeue itself, it frees. See this statement. It is very powerful statement. It frees all the memory. Understand? While dequeuing only, it is freeing the memory which was earlier assigned by malloc to our new node. So all the memory which was utilized for this queue is now freed by this free function. Understand? Now this function executes, this free queue function executes when we want to completely delete our queue. Understand? So this was what happening in our queue. Let's go to our revision and let's write what is a queue? Is a what is our queue?
Data structure.
No, it's a linear data structure again.
Uh,
You you just see it here. It's a what? It's a linear data structure. Okay, let's write is a linear data structure. It's not a data type, it's a data structure. Data structure that follows what?
FIFO.
FIFO, that is first in, first out, or last in, last out principle. Okay, then we can implement stacks in arrays or linked list. Oh, we can implement in arrays or linked list. Then some operations which we can perform on QR. We can we can what? NQ operation, and then what? DQ operation, and then peak operation. So this was it for Q. Understand?
Yes.
So we talked about arrays, and then we saw a very good algorithm on quick partition, and then we talked about linked list, which are of two types, singly and doubly, and then we talked about stacks. We could perform some operations on stacks such as push, pop, and peek. We could imagine stack as what? We could imagine stack as a glass in which there are different flavors of ice cream in different layers, and then we could only retrieve the flavor which is present at the top. Okay, and then we have queue, In Q, we could imagine Q as like water, um, and pen pencil which has some lids which are in section, and when we remove the front lid, a new lid appears. So that is what? That is Q. Yeah, that's it about today, I guess. Let's end this over here then. Okay, satisfied?
Yes.